Hey, how's it going, everybody? So, coming with you today, the last part of the air masses and fronts lecture. So, we're going to be looking at kind of what a cyclone is, kind of in a bigger picture. Cyclone a lot of times kind of gets misused when we think of like tornadoes. Cyclones are actually normally larger weather systems, things like hurricanes or basically storms that can produce tornadoes. The tornado is actually kind of the event on the ground. The cyclone is the larger actual picture or the bigger picture of the storm. Yeah. So in cyclones form, what we have is normally we have like a colder air mass pushed into a warm air mass. We have this cold front here, and we have normally the warm front next to it. So this kind of shows it's going to become occluded. So we have a warm air mass between two colder air masses. So we have a colder mass right here and a colder air mass up to the top. So as this begins kind of pushing into it, so it'll start to actually rotate. And that's where we get this occluded front here, is as they kind of begin pushing together, eventually the cold air mass catches up with the warmer air mass, right? And it causes that basically kind of change direction, but it causes it to begin rotating. So we kind of see this rotation here where it's beginning to turn to that occluded front. So it does, it'll start to create kind of this rotational pattern. And you kind of see right here, this colder air pushing and warm air will kind of sometimes help prevent that, but it could also increase the speed at which it rotates. So kind of looking at this in kind of the steps, so the first thing we have is we just have our stationary front. So the surface view is basically looking on the top down. So if you're like in a helicopter looking down at the ground. Okay. So we have again the cold air kind of moving in one direction, so it's kind of pushing here to the left. Overall, the cold air wants to move kind of this downward, where the warm air wants to move up. So they basically begin moving past each other. So that's kind of a little boundary that begins to exist. Right. So then we have the kind of waves start to form. So we have that boundary, but now we can see it's actually shifting to kind of a warm front and cold front. So the cold air begins kind of pushing more downward, and then the warm air kind of begins pushing up. And you see the warm air will naturally start to rise over the top of that colder air because it has that lower density. So that's what we're kind of seeing, and we're creating this little bit of a rise here, but it is starting to create a little bit of a rotation that's common in cyclones. All right, so step 3 is it actually begins to mature, so we start seeing that warmer air rising, colder air pushing through, so we have that cold air pushing into this, pushing underneath of that warm air. It's again starting to create more of a true cycle, or that cold air begins pushing under, with the warm air pushes up. I mean, this is where we're going to start creating some storm cells, or like storm systems, because we're going to have this warmer air rising that's going to cool down, and it's going to start creating clouds. So then we have the actual occlusion catch up, because the cold air has caught up with the warmer air. So we're going to see it's almost going to work like a zipper, where it's going to become occluded over time as the cold air catches. But again, this cold air then is going to be getting pushed through, coming around from behind here, and creates again that cycle or that rotation, which is common, or creates a cyclone. Again, the cold air dominates. We're near the end, and the cold air is being pushed through. That warmer air is now getting trapped and being forced up very, very quickly. So when we look at this, we can kind of see, here's an example of a cyclone where we have the cold front here, the warm front that's kind of getting pushed. So this cold front is pushing north, catching the warm front, and here we have the occlusion where it's already caught it. So we have a lot of storms or rain there as well. And you kind of see here that rotation, or that rotational pattern. That's kind of what we see in the upper Midwest. Okay, so this is kind of looking at a different version of a weather map. So kind of go through this pretty quick. So we can get to the last part where we have the questions. Alright, so we have a cyclone that's centered just south of Wichita, Kansas. So Wichita, Kansas is going to be like right in here. So we're going to say right here you can see is where the cyclone is centered. That's where it's going to be rotating around. Alright, so we can actually see the fronts are very well developed here. So the coloration actually shows temperature. So it's kind of very easy to see the differences in temperature as well as the differences in pressure. So you can see up here it's kind of cooler. You can see 31, 20 if you look carefully. Where down to the Gulf you have 70. I don't really see anything right in there. So this is looking 6 hours later. So a mature cyclone at this point with weather fronts. So again, we can see the fronts as well because the changes in the coloration are the very easy fronts to see because it's a change in temperature. You can see as the cyclone, which is right here, is beginning to, you can start to see that rotation. Right, so it's beginning to come down and kind of rotate around. Right, so as it continues to develop, here it's moving into, you can almost see now it's almost into Iowa. But you can see that cold air rotating and pushing through the warmer air. Right, it's actually kind of coming around and chasing the cold air up here. Again, you can see it's continuing to push as it goes through, but we create that kind of cyclone. And now the colder air mass is taking over, and we'll get the cooler weather with some rain or snow. And here now, basically, that cold front is completely taken over. It's pushed everything to the east. And so it's kind of looking how that one storm developed slowly over time. You can see here, and we can look at it a little bit quicker. So it forms, and we have well-defined fronts. The cyclone is just kind of beginning to form. And you can see here it's rotating. And it continues, and then now it's pushing off to the east. Okay. So when we're finding fronts, there are a couple of things. One of the key things to look for is a strong temperature gradient. Right. So we're looking at here as a weather map. You can see Minnesota is top center here. The yellow lines indicate temperature, whereas the blue lines indicate what we call pressure. So we're looking kind of at that, temperature gradient where it's a sudden change in temperature. So you can see like where A is minus 10, minus 5, 0 degrees up here. It's over kind of longer gaps. At B it goes 15, 20, 25. It goes basically from 15 to 50 in this small gap right here. And C, you can see it's over here, 55, 50 is pretty consistent throughout. So first question I have for you is, do you see or which letter is closest to where the front would be? Okay. So now looking for the second part here is, would you agree that the air mass in the Dakotas, so that's going to be looking like right up here, is not the same as the one that exists near Kentucky? So Kentucky is looking over here. So the question is asking is, are the air masses, do you agree that they're different between the location over here by Kentucky and the Dakotas? And then just simply state, why do you think it's different? Okay. So looking at the answers to those two questions, so we can see the front is located right along B. So we have this sudden temperature change between, looking at the Dakotas where it's very, very cold. It's minus 10, minus 5, versus over here in Kentucky where it's in the 50s. So there's a big temperature change. You can see all these lines closer together. That means that there's a temperature change right there. And the air masses are going to be different. Here we have one we know for sure that's going to be either a polar or Arctic air mass because it's very cold. Here we most likely have a tropical air mass. And I'm not sure what the moisture content, so we don't know if this will be a continental or a maritime. Same thing down here. Okay. But both of those but B would be the answer to the front, and then the air masses are different from each other. Okay, I confused myself for a second. Okay, so number 2 now, when we're looking at, like say dew points. Remember, dew point again is looking at the amount or the temperature at which water condenses or becomes a dew. So remember, anytime we see that change indicates a front. So again, in the Dakotas here, we see minus 20, minus 15, minus 10. Right, whereas down here in basically Mississippi, Louisiana, Kentucky, Tennessee, we can see it's anywhere from 30 to 40. Right? So first question is, do you see a front here? So where do you think the front is located? Right? And then if you do see the front, is it roughly in the same location as the temperature one we saw on the previous page? So go back real quick to that. So we can see it says kind of right in here. Right? Is it still in that same location? Okay. So looking at the answers to questions. So first is the front again is location B, where we see that sun change. It goes from minus 5 to all the way up to 55 over here. So it's kind of over a short area, it's a pretty big change. So the front runs right kind of along these narrow lines. Then was it the same location as the previous slide? And we can tell that it is basically run through the same area, kind of through Kansas, Arkansas, Iowa, up into Minnesota. And you can see it run through the exact same states right down here. So the last question, or last part for these, so rule number 4 or 3 was, find fronts of strong pressure gradients with a, strong falls followed by a strong rise. So the pressure is going to be suddenly changing. So one thing we can look at is the pressure, and the pressure is the blue lines, which are kind of harder to see. And another thing we can look at is the wind. So the wind is the yellow lines. The longer the lines are, the stronger the wind is. Alright, so we're looking again here. Do we see where the wind changes, or wind suddenly changes direction? To be an example of a front. So looking at these questions, do you see where they are here? Right? Yep, and we can tell that along B again is where we have the fronts, because we have our, basically the pressure is or the sudden change in pressure between, like right here, it goes from 4 to minus 0.5, or minus 1 up to 4. So along these narrow lines is where we have our front. Again, we can see the wind to the northwest is blowing kind of mainly from the northwest to the southeast. Where we go and look down to southeast, it's doing the opposite direction. And that wind changes right here in the center. Okay, we can see here, again, we had our cold front, is what we actually had. That's pushing down from the northwest to the southeast. We have a warm front here that's kind of pushing kind of from the northeast, further northeast. So we can see where we had stay occluded, and the cold air is actually catching the warm air. Okay. So if you have any additional questions with this, please let me know. Otherwise, I'll add more on for next week. Have a great long weekend.